We are again in section 4.4, and today we're going to be focusing on finding reference angles. The point for reference angles is, again, if I ask any given trig function and the angle is extremely large, that we use this technique of finding a reference angle to bump that value back down to a coordinate from the unit circle, and then that way we're able to figure it out from our memory. So to find a reference angle, a reference angle is a non-acute angle in standard position the reference angle is a positive acute angle, and the symbol we use for a reference angle is the theta with a little tick mark next to it, formed by the terminal side and the x-axis. So I'm going to draw out how to find the reference angle in each quadrant, and this is not something I want you to memorize. I think it'll be easier if you always are graphing the angles and you figure out what quadrant they're in. It'll be easier to kind of figure out how to find the reference angle. So if we have our reference angle, so there is no reference angle for quadrant 1 because that's an acute angle. The purpose of reference angle is when you're non-acute, meaning you're larger than 90 degrees or larger than pi over 2. So if I'm in quadrant 2, my terminal side would end up in quadrant 2. And the way we would find the reference angle is, if you're in degrees, 180 degrees minus the original theta, or pi minus the original theta. And that will give us the value of that little piece right there. Quadrant 3, so the terminal side will be down here. To find our reference angle in quadrant 3, you do the angle minus 180 degrees, or the angle minus pi. And that will give us this little piece there, because remember the definition says it's the amount of degrees or radians between the terminal side and the x-axis. And then lastly, quadrant 4. Our angle is here. So to find the reference angle in quadrant 4, we do 360 degrees minus the angle, or 2 pi minus your angle. And that will give us this little piece right there. So we're going to practice a few problems of finding the reference angle when they are less than 360. Then we're going to work on building in coterminal angles in addition to the reference angles. So for our first example, our theta is 345 degrees, and they want you to find the reference angle. So easiest way I think to go about this is to graph it. So 345 would be somewhere in quadrant 4. So if this is 345 degrees and this is 360, remember your reference angle is the distance between the terminal side and the x-axis. So that amount of degrees would be 15 degrees. Now if you wanted to use the formula says if you're in quadrant 4, you do 360 minus your angle of 345, and that's how we'd get the 15. So it's a pretty basic one. Let's try one in radians. So in radians, our angle is 5 pi over 6. And again, they want you to find your reference angle. That should be a period, not a little dot. So let's graph it, because I think that's one of the easiest ways to kind of visualize. So remember, this is 0, this is pi, which means this is 6 pi over 6 for those common denominators. This is 5 pi over 6, not 5, sorry, 3 pi over 6. So between 3 and 6, we know 5 would fall a little bit closer to the 6. And I'm looking for this distance right here. So if I'm at 5 pi over 6, I only need 1 more pi over 6 to get me to that x-axis. So our reference angle is 1 pi over 6. Now again, you could use the formula, quadrant 2, the formula says you take your angle and you subtract, you do pi minus the angle. So we would have pi minus 5 pi over 6. We would change this to be 6 pi over 6, and then you subtract them and you get the 1 pi over 6. So one more. So the last type you're going to see is negative angles. So if my angle is negative 135 degrees, again, asking you to find the reference angle. We draw a picture. I know negative 135 degrees is in quadrant 3. So here is negative 180. And I'm looking for the distance between the two. Well, I know that from 135 to 180 it would take me 45 degrees to get there. So that would be our reference angle. Other way to go about it is, again, doing 180 minus our angle of 135, and that's how we'd get the 45. So pretty straightforward. Next thing we're going to do is finding reference angles when they're larger. So instead of writing it out, I think I'm just going to show you a few examples, and I think we'll be able to blend right into that. So for this one, our theta is 580 degrees. So one of the first steps we do is we know coterminal angles are angles that lie in the same spots, just one full revolution separates them. So if I wanted to figure out where this was going to fall with a smaller revolution, I would take out 360. So we're going to do that first. We're going to say, okay, well, I know if I subtract 360, go back a revolution, the terminal side is going to fall in the same place. So I get 120 degrees, 220 degrees. Okay, so now I'm less than 360, so now we're going to figure out where this falls. So 220 degrees is going to be in quadrant 3. So remember, the only difference between these two is if I did 220, that would be like this, versus if I graphed the 580, it would look like that. But regardless, the terminal side and the x-axis is what we're looking for. So I'm looking for the gap between these two. So the amount of degrees between 180 and 220 would be 40 degrees. And that's our reference angle. If you did it with 580 and 180, you're going to get 400 degrees. And that's too large because one of the rules says for a reference angle is that it has to be an acute angle. So that's why we have to take out that revolution first. So one more. So our angle is 8 pi over 3. And again, they want you to find the reference angle. So again, 8 pi over 3 is more than one revolution. So we know one revolution is 2 pi. And if I got common denominators, that's like a 6 pi over 3. So too big. So first thing that we're going to do is subtract that out. So I'm dealing with an 8 pi over 3. And I'm going to subtract the 2 pi. Change this, get common denominators. So 8 pi over 3 minus a 6 pi over 3. We're working with a 2 pi. over 3. So we're going to figure out where that falls. So I know this is 0, and I know this is 3 pi over 3, which reduces to be pi. So 1.5 pi over 3 is up here. So I know that 2 pi over 3 falls there. And again, I'm looking for this distance right here. So this is at 2 pi over 3, and I need to get to there. So that would take me a distance of 1 pi over 3. So that's our reference angle. So we're going to work more with this in the next video tomorrow, and I'm going to show you the actual application of finding the reference angle. So that's all for today.